Hi guys, so what we will do today is I thought let me shoot a video of me explaining the questions rather than doing it in class, where a lot of students did score good marks, over 70-80%, some scored 100%, so let me do a quick video to support the students. Start with the first question. So box standard good question from the examiner, a very good question. The examiner gives you this question, should be an absolute gift. So explain the brackets. So e squared plus 3e minus 5e plus or minus 15. You get 1 mark actually for writing this. So you get 1 mark for writing this, or you can give the answer immediately as e squared minus 2e minus 15. Nice and easy question to start with, and we should be all happy with this. It says show and solve straight away. You have a fraction over 1 equals 2y plus 1 over 5. Easy peasy, everyone should have got this right. 2y plus 1 equals 5y. Bring the y over, so 1 equals 5y minus 2y, therefore 1 equals 3y, therefore y must be equals to 1 over 3. Nice and easy one there. It tells you equal to 0, so I'd straight away see it seems like it's factorizable. So two numbers that make 18 have a difference of 3. The only number is 6 and 3, so x, I'll have 6 here and 3. It's a plus, so that's given to the bigger number, inherits the sign, so therefore x equals negative 6 and x equals positive 3. Everyone should have got 8 marks here. Make y the subject. Okay, we have y equals root of 2x plus 1 all over x minus 1 all over 1. Okay, first and foremost, I will square both sides, so y squared must be equal to 2x plus 1 over x minus 1, and then cross multiply to get y squared, open brackets, x minus 1 is equals to 2x plus 1. Expand the bracket, so x y squared minus y squared equals 2x plus 1. Now we get the x's together, so we're left with x y squared, so send this one over, and we're going to send the y squared over, so x y squared minus 2x is equals to 1 plus y squared. Now getting the x's, so x open bracket y squared minus 2 is equals to 1 plus y squared. To make x subject, we're going to divide everything by that bracket, so x equals 1 plus y squared over y squared minus 2. There's many variations, some have positive at the bottom, some are negative, but obviously if a mark 2 are correct, that means there's an other equivalent mark here. Next one, for some reason people ask me, sir, why is already the subject? How can I make y the subject? It's not already the subject because you have y inside and y outside, so it's not the subject. Therefore, if I expand the brackets, y equals square root of a y squared plus n. I need to remove the square root, so I want to remove the square root. I'm left with y squared equals a y squared plus n. Bring this one on this side, we have y squared minus a y squared equals n. Factorize the y, open bracket, if take y squared, okay, let's take y squared outside, open bracket, 1 minus a equals n. Divide everything by 1 minus a, so y squared equals n over 1 minus a. This is not the complete answer. I don't want y squared, we want only y, so we can obviously go ahead with square rooting, and they said here actually the positive value, so we don't need plus or minus, so y equals root of n over 1 minus a, and that's it. Nice and easy, 5 marks, done. This caused a problem for some students. We have 7 plus 12 minus 3x squared. Okay, so I'm going to switch this over, so minus 3x squared plus 12, and then complete the square. So first and foremost, 7 minus 3, open brackets, x squared plus 4. Now, if you put a plus here, okay, you will lose a mark, and a lot of students done that, because minus times plus is minus, and we need a plus. And so we need to remove this, okay, from plus to minus, because minus 3 times minus 4 is plus 12. And now we are done. So let's now complete the square. So 7 minus 3. Set up your squared brackets and then set the inside and put a minus. And again, we half the minus 4 to make it to minus 2. And we square the minus 2, or just square the 2 to give me 4. Now expanding the bracket, 7 minus 3, open bracket, x minus 2, all squared. And minus 3 times minus 4 is plus 12. And therefore we have 19 minus 3, open bracket, x minus 2, all squared. And we're done. And then it says the minimum. Our student told me, sir, you've never taught us maximum point. The student's not reading the question. Okay, to one marker, maximum point and minimum point are the highest points. Why did we go ahead and do all of this for 3 marks? Okay, the idea is to ascertain a point. We follow the same rules. I told you what's inside the bracket turns positive, and what's outside stays the same. So the answer is 219. This one here was a very poorly answered question in the exam. Now, when you see 3 marks only for this question, what comes to your mind here is that you must think about, why is sir giving me 3 marks with 1, 2, 3 fractions? That means there's something that we need to look at. X squared minus 36, you should have all factorized it as x minus 6 and x plus 6 minus 2 over x minus 6. You should have realized that, there's a collect like terms here. Okay, so let's collect like terms. Okay, over, so I'm gonna do is I'll take the highest common factor between them. That's gonna be x plus 6 and this one. Clearly going from here to here I times by 1, so from here to here I'm gonna times by 1, that'll be 20, minus here it's x minus 6. If I cover the x minus 6, right? If I cover the x minus 6, what am I left with? X plus 6. So this is like saying times it by x plus 6, right? So whatever I do on one side, do the other side as well. So I'm going to times it by x plus 6. So now I've sorted out this section. I need to sort out the last section, which is 1 over 4 minus 6. Okay, expand the top. So 20 minus 2x minus 12 over x minus 6 times x plus 6. Okay, times 1 over 4 minus x. Simplify. 20 minus 12 is going to be 8 minus 2x all over x minus 6 and x plus 6 and times by 1 over 4 minus x. Now what I'm going to do is factorize the top. So I'm left with the following. So 2 outside, 4 minus, wow, I can see the numerator is exactly like the denominator in the other fraction. So times of 1 over 4 minus x. Now this cancels out nicely with this, and the answer is going to be 2 over x minus 6 times x plus 6. And that's done. Or you can leave the answer as 2 over x squared minus 36, and both are accepted here. But the idea is, I've seen people expanding cubics. The examiner will never let you expand cubics. Once you expand cubics, that means you're out. Okay, look for collect like terms, collect them together, and then see what you have. This question caused a problem also for students. They had a heart attack. Why is sir giving us circles with quadratics? Who cares? The diagram shows a circular pond of radius r surrounded by a circular path. The circular path has a constant width of 1.5 meters. Okay, the area of the path is 1/10 of the area of the pond. That's fine. The area of the path is 1/10 the area of the pond. So it should give you an indication what that means. So area of a circle, everyone should know, is pi r squared, right? Why are we faffing about with a very simple formula? Okay, so the area of the path is 1/10 the area of the pond. So the area of the path is 1/10 the area of the pond. So what we're going to do here is we're going to create 2 equations. Now the 2 equations that we need to create is going to be the following. So we will have pi, right, times, open brackets, r plus 1.5 all squared minus pi r squared equals a tenth. I'm going to leave it as 0.1 times pi r squared. So what did we create here? We created the following. We said that the area of the pond, the area of the path, so this one, how do we get the area of the path? First, you have to find the area of the entire circle. The area of the entire circle is r plus 1.5. So r plus 1.5, that's our new radius. And then we're going to take it away from the area of the pond. The area of the pond is just this section here. Again, so we had to find the entire area. So this gives us the big circle. That's going to be all of the radius from here to here will be r plus 1.5. Okay, we had to find the entire thing. And then we're going to remove the center circle. That's just pi r squared. So that, take away that, will give us the path. And then again, the pond is a tenth. So simplifying this will give us the following. So if I quickly calculate it for you, 1.5 squared is 2.25. So we're left with r squared plus, firstly, let me just make it easy for myself and divide everything by pi. So that, therefore, I remove the constant pi from each of the situation. Expanding that bracket would be r squared plus r squared plus 3r plus 2.25 minus r squared equals 0.1 r squared. So now all we're gonna do is you'll see that this r on this r cancels out. We're left with 3r plus 2.25 is equals to 0.1 r squared, and we should be, if we times everything by 2, we should be okay in that sense. So the r squared will cancel out that r squared, which is fantastic. And then as you simplify the equation, you should be able to return to times, well, let's fix this up, plus 2.25, okay, is equals to 1 over 10 r squared. If I times everything by 10, that will give me 30r plus, this is times once, okay, 22.5. 22.5 is equals to r squared. Then we want to remove this 22.5r, sorry, 22.5r, this 22.5, I want to remove it, so I'm going to double it. So 60r plus 45 is equals to r squared. Bring everything on one side, so bring this one here and bring this one here, and r squared minus 60r minus 45 equals 0. So again, this question, it seems hard, but you don't even need to, okay, in the exam, worst case scenario, you can't do this. The formula is there given to you. Okay, so let's now solve for 2r squared minus 60r minus 45 equals 0. It says 3SF, so we must use the quadratic formula. So minus, open bracket, minus 60 plus or minus root of minus 60 all squared minus 4 times 2 times negative 45 all over 2 times 2. Put this in your calculator, you should get a solution, a nice solution of 2 areas. So you get r positive, obviously a positive value, 30.732, ... do not round it please. And now we've got the radius. We can't do nothing with the radius, they want the area. The formula is pi times r squared, so pi times 30.732 all squared. And then I should put this in the calculator, you get a nice value as 2967.12. A lot of students don't know how to round to 3SF. So 3SF, that's the first one, that's the second one, that's the third one. Stop. Here, that's your line. The 7 we can't ignore, so we have to pump it to the 6. The 6 goes up 1 and the 7 turns to 0. So 2970. That's the solution. Okay, surprisingly, students got this wrong as well. 5 minus x and 2x minus 3. Okay, let's expand the first one. So as I told you, start with 2 first and then deal with the next one. So 5 minus x, I'm going to leave it for the end. That'll be 2x squared plus 8x plus 3x is plus 11x plus 12. Okay, expanding the last one, it's going to be 10x squared plus 55x plus 60 minus 2x cubed minus 11x squared and then minus 12x. Okay, so that will give me the following. So negative 2x cubed stays the same. 60 can stay the same at the end. I'll just do 10, take away 11. That's going to be negative 1 x squared. And finally, 55 subtract 12 will give me plus 43. And I'm done. Nice and organized. I've seen a lot of work, students, unnecessary work, wasting time for no bizarre reason. The exam is compact. I'm already like question 17 and this recording. Okay, I'm a maths teacher, but I'm just saying you have to make it work for yourself. You have to find ways to work smartly. Okay, this question caused some issues, unnecessary issues. So we have G equals C plus 3 over 4 plus C minus 7. Now, what does this mean? We can't put the 7 with the 3. It's not, you can't connect. This is a fraction and this is a number, right? You can't connect them. Send the number on the other side. So we're left with G plus 7 equals C plus 3 all over 4 plus C. Now put it over 1, cross multiply. So G plus 7 times 4 plus C is equals to C plus 3. Okay, so now we expand the brackets. So 4G plus CG plus 28 plus 7C equals C plus 3. The target here is to make C the subject, which means to us the only values that have C is this one and this one. That means they have to become closer, okay? And also C here as well. So what we're going to do is we're going to leave 4G plus 28. So I'm going to leave these two on here. So this one and this one I'm going to leave. And this one and this one and this one I'm going to send over. So I'm going to send this over here. And finally, and the 3, I'm going to send it to this side. So we're left with minus 3, okay, is equals to C minus 7C minus CG. This will give us 4G plus 25 equals. So let's simplify as C take away 7C. Okay, that's going to be 6C. And we have CG on both sides, so we can easily start to reduce it. So we will have the following. Well, if we reduce this one, it will be C minus 6C minus CG. So 4G on the top, 4G plus 25 is equals to, if I take out minus C on this side, then I'm left with 6 positive plus G. Now I can divide everything by minus, so 6 plus G over 6 plus G, that cancels out. But we're left with minus C, and we don't want minus C, we want positive C. So if I put a minus here, it will cancel out this minus. So the answer is minus 4G plus 25 all over 6 plus G. That's a tricky one, okay? But again, slow and steady wins the race. So now the next one, again, very similar to the first one. It asks for you to create a quadratic equation application. The diagram shows a rectangular playground with x centimeters and the length 3x. The playground is extended by adding 10 meters to the width, so 10 meters, so x plus 10. and 20 meters to its length, so plus 20. What's that hard? I don't know if that's hard. And the area of the larger rectangle is double the area of the original playground. Fantastic. So this means initially, before the extension, the area of the playground is x times 3x. Okay, so the area was 3x squared initially, but now it's extended. So it says the area of the larger rectangle is double the area of the original, which means now the original one is actually 2 times 3x squared. This is equals to the new area. So we will say 2 times 3x squared is equals to x plus 10, the new extension, and 3x plus 20. Now if you simplify this, 6x squared is equals to 3x squared, 20 times x plus 30 is 50, plus 200. Okay, now all we're going to do is bring everything to one side, to this side, to this side, and to this side, and we're left with 6x squared, take away 3x is 3x squared, minus 50x, minus 200, equals 0 as required. Okay, now they've given a quadratic. If you can't solve it, use this here. Put it in a quadratic formula, man, and solve it. I don't know what's the problem. Okay, so it seems like it's factorizable. So I'm going to factorize it as follows. Because 3 has only one factor in itself, so it has to be 3x here and x here, and plus 10, and has to be minus 20, equals 0. So x equals negative 10 over 3, and x equals 20. Obviously this one we can't take because we can't have negative area. But now we found x is 20. They don't want x, they want the area. And so the area of the original playground, we said was 3x squared. So what we're going to do is just times 3 times our x is 20, all squared. That gave them 1,200. Very nice and easy to go. Okay, this question, we've done 100 of these questions. I'm surprised people got it wrong. It's shocking. It's so bad, and we need to start focusing and taking things seriously. Okay, so let's go. X plus 1 and 2x minus 3. So 3 open bracket 2x minus 3 plus 2 open bracket x plus 1. All we did is this times this, this times this, and this times this, and this is all equals to 1. Expanding the top, 6x minus 9 plus 2x plus 2 equals 1 over x plus 1 and 2x minus 3. Okay, simplifying further, 6 plus 2 is 8x minus 7. Okay, 8x minus 7 all over x plus 1 and 2x minus 3 equals to 1. Plus multiply, so 8x minus 7 equals, expanding the bottom is 2x squared minus 3x plus 2x is minus x minus 3. And now bringing everything to one side, therefore it's going to be 2x squared minus 9x plus 4 equals 0. And again, this is factorizable. It's a special one because 2 only has its factors in itself. So we can use the original way of factorizing, and it minus 1 and minus 4. So x equals positive 4 and x equals negative a half. 5 marks, it's so easy. Okay, this one is interesting question. Technically, basically telling you to solve a simultaneous equation, but we'll have to see what it is. So let's call this one x, all of these sides x. Okay, and these small ones we're going to call y. So again, y here, and x is the big ones, and this is y. So we can say if I add x plus x plus x plus, yeah, so plus 2y, so 3x plus 2y, that must equal 29. So 3x plus 2y equals 29. And similarly, I'll do exactly the same. I have 2 y's here and 1x. So 2 y's and 1x. So that will be, therefore, I can write my second equation, 2y plus, what, sorry, wrong side. So 2y So only have 1x plus 2y equals the solution of 15 centimeters. Okay, perfect. 2y's will cancel out, start reducing the fractions. That will cancel out simultaneous equation. So 2x is equals to 29, subtract 5, that's 4 and 1, so x is equals to 7. Now to get y, okay, we can choose any equation. So x plus 2y equals 15. So I have x is 7 now, I can replace it. And I can do 15 subtract 7, it's going to give me 8 equals 2y, so y equals 4. And that's the equation. It says work out the area of one of Kelvin's rectangle tiles. So we want one of these, okay? We want one of these. But we already know the base. This is said x and this is y, right? This is x and this is y. We know what x is, 7, and this is 4. So 7 times 4 is going to be 28, and that's it. We're done. This is the last question. Okay, exam's quite short actually. Okay, this one's very, very, very easy. I don't know why we got this wrong. I don't know why we're rushing in the exam. It's a very bog standard non-linear equation. I'm going to send everything on one side. So my equation is going to be x equals 1 minus 2y. Now every time I see an x, I'm going to replace it with this. So I'm going to replace it here, I'm going to replace it here, and that's it. So 1 minus 2y, that's squared, so I'm going to square it. Okay, minus 9y minus, that's x, I'm going to open bracket 1 minus 2y. Remember, this minus is going to cause me an issue. This minus is going to cause me a problem, okay? So we need to put it around brackets. It's so important. Continuing, equals 2y squared minus 12. Expanding this one, 1 minus 4y plus 4y squared minus 9y minus 1 plus 2y equals 2y squared minus 12. Okay, very good. Simplifying further, okay, I'm left with 1 minus 1 cancels out, perfect. We have 4y squared minus 13y, or plus 2y, so 13 plus 2 will give me 11. Okay, so now I've combined this section, equals 2y squared minus 12. So last but not least, bring the 2y squared here. So we have 2y squared now because minus 11y plus 12 equals 0. So we have a quadratic equation, and it seems like it's going to be factorizable because 2 only has one factor itself and 2. So we can technically factorize this one so that we can get a solution. Again, in the exam, you can use any means of solving here. You can use anything you want. Factorizing, expanding, all that stuff, whatever you want here, it's not a problem. So when we factorize this one, we should have 2y minus 3 and 2y minus 3 and also y minus 4. So therefore y equals 3 over 2 and y equals 4. So that's the first solutions. We haven't finished because we need our x values. So therefore 1 minus 2y. So putting 1 minus 2 times 3 over 2 and 1 minus 2 times 4. That will be 1 minus 3 is minus 2. And here x is going to be 1 minus 8, which is equals to minus 7. So y equals minus 7. So our solutions at the end, I'm going to write them as a couple. So x, I can write them as a coordinate if you wish. So minus 2 and 3 over 2. And that should be x actually, not y, x. So minus 7. And x is minus 7 and y is 4, and that's it. That's the solution done, and that was the exam solved for you. and I'll upload this for you online with the model solutions if you wish. If you have any other problems, please do find me, and I hope this video actually is useful. And as always, you bloody breathe some mathematics. Take care, guys. Bye.